Hi, in this video, we're going to talk about the operation of traversing through a linked list. So we know in a stack, the client code can only access the top of a stack. However, in a linked list, it is not limited to just that. In a linked list, all the nodes and all the data, as a matter of fact, can be returned to the client for its consumption. So this operation of providing access to all the nodes or all the data is called a traversal, right? It basically just goes through everything in the linked list. Now, we've actually already seen an example, a limited example of that, and that is in the dunder string method that, it turns all the nodes, all the data in the linked list into a single string, right? Now, the dunder string method does the traversal internally, but in general traversal, the difference there is that it, again, provides to know all the data for the use or consumption eventually by the client code. So how does client code do the traversal? Well, the general idea is captured in the following pseudocode. So first, the client code would initialize some sort of traversal state. Okay, so it usually, like in a linked list, it will probably start at the head of the linked list, right? And then it will go into a while loop, and it'll stay in this while loop as long as there is some data, right? And so the first thing it does in the loop is it will retrieve the data, the current data, and then it will do something with the current data, print it out, do some calculation, whatever, right? And then after it's done, then it will update the traversal state so that it'll prepare to return the next piece of data, right? And then it'll go back to the beginning of the loop and it will check, okay, is there still data? If there is, then it will repeat this process over and over until there is no more data. So that's from the client's perspective, how a traversal should work. So how would the linked list provide a functionality for this? Well, first let's look at what the traversal state is. Um, if we want to visit the whole linked list, then the state that we should maintain is like what we did in the dunder string method, that it's a pointer pointing to quote unquote the current node, right? So and the current node, as we said, it should start at the head and then goes to the node after the head and then after that. Now, this traversal state, because we are going to have to maintain this state across many different calls, so we should also make it an attribute of the linked list so that it persists. So let's start with the initialization of this traversal state. We're going to call it reset current because, again, the current is the current node that we're visiting, and we'll start naturally at the self.head of the linked list. So next, we'll provide a way to return the current data. And as a matter of fact, in the same method, we will also update the traversal state to prepare to return the next piece of data, if there's a next piece of data. So the way to do that is we're going to write a iterate method. And this iterate method is, well, the first thing is it remembers self.current.next. Now, the reason it doesn't remember what's in self.current is that, remember, we start current at the head. And the head pointer, remember that it only is a placeholder node, that it does not contain actual data, or it will not eventually when we write the data linked list. So that's why we don't start at the head, but we start at the head.next. And so current.next is really the quote unquote the real current node. And then to prepare for the next call of iterate, we're going to advance the self.current pointer to self.current.next, which has been assigned to temp. So that's why we're just assigning temp to self.current. And finally, we return the current node or eventually the data. So with reset current and iterate, that's enough for the client to retrieve every node in the linked list. So the way to do that is, well, let me demonstrate that we'll initialize a linked list. We'll add a bunch of nodes to the head, and then we reset the current so that we start at the head, and we're going to go into a loop. So the first thing we do in the loop is we call iterate, and it will return us a node and also move the current to the next one. So now if the node is nothing or none, then we're done with the traversal, and so this loop terminates. Otherwise, for now, I mean, all we're doing is let's print out what's in the node. So let me run this, and indeed, it because we added 3 nodes, and so it's going to print out the 3 nodes that that we added. And here's a question for you: as with all client code, we cannot assume that it will always do the right thing. So what if, for example, after it's done iterating through the entire linked list, it does one more iterate call? What would happen in that case, and how do we fix it if we want to fix it? So pause the video and please give that a try. I'm assuming you have done that. So what happens is that, let me uncomment this, and if we run it, it will complain because, well, we break out of the loop when the node is none. So, and here, and that means the self.current is none already, right? So here we get into iterate again, and then if the current is already none, then it will try to do none.next, and obviously it's not, the none object does not have the attribute next, and it's going to raise an exception and crash. So if we want to not crash in this case, then what we can do is to check the self.current first. So if it is none, then we could do a number of things. We could return none, or I guess return none would be a sensible thing to do here. So we can just run that, and in this case, we protect ourselves from crashing, which is fine. Now, that's a design choice. We don't always have to do this. Like we saw previously in actually iterables, that it's okay if we reach the end of a iteration and we can signal the end of it by raising an exception. So that's also okay. So either way is fine. It just kind of depends on what you want to do with your project, or what your project manager or product management tells you to do. So now another thing I really like you to do is to actually either manually by hand or in a debugger step through the execution of this code, and like I said before, draw pictures, and especially what node that the self current, the traversal state, is pointing at, and just make absolutely certain that you understand how the traversal work and how both the reset current and in particular the iterate method works. Now, so we did the traversal for a linked list without data, which returns all the nodes, but that's not terribly useful. So the next thing I'd like you to try is to do the list traversal for the data list. So think about what we might have to do for reset current as well as iterate, so that the client code can use these 2 methods to iterate through the data in a data list. So pause the video, please, and give this a try. All right, so hopefully you have had some time to think about it. So for reset current, there is really nothing to do there because it simply sets the current pointer pointing to the head. So that's the same whether the list has data or not. Now for iterate, we want to return the data from the node. So we can just call super.iterate, which will return us the node, the current node, and then extract the data from it. So that's what we'll do for the data list iterate. Now to use it, it is slightly different because remember, when we reach the end of the list and we call iterate again, in the linked list, we get a none no. And when we try to dereference none.data here, we're going to get an exception. So for the traversal of the data list, then we will put this data list.iterate in a try except block. So when we get an exception, we know we reached the end of the list, and then we can exit out the loop. So if you want to see this in action, I've written it out here. We insert, add all of these numbers to the head, and then we go through this data list. So we obviously, because we added to the head, it's going to start at 5533 and then all the way back to 66. So one last thing I want to say about list traversal is that visiting every node or data in the linked list really kind of sounds like an iterable, right? So instead of using a while loop and calling reset and iterate, all that, it would be really nice if we can achieve the same result, but by just writing a for loop. So for each piece of data in the data list, we do whatever we want to do with the data, right? Anyway, so a class on the data structure in Python will go into a lot more details on this topic. It might be simple enough that we may give this a try in this class as well. We'll see.